Hi, ChatGPT. I'm recording a video about using your services to assist with modeling in Grasshopper. Is there anything you could tell me about Grasshopper?
Sure, I'd be happy to help with your video about using Grasshopper for modeling. Here are some key points and interesting facts about Grasshopper that you might find useful. What is Grasshopper? Grasshopper is a visual programming language and environment integrated with Rhinoceros3D, Rhino, a powerful 3D modeling software. It enables designers to create parametric and algorithmic designs through a node-based interface without needing traditional coding skills. Key features of Grasshopper. 1. Visual scripting. Users create and manipulate algorithms by connecting components, nodes on a canvas, which represent different operations like mathematical functions, data manipulation, and geometry creation. 2. Parametric design. Grasshopper excels in parametric design, allowing users to define relationships between design elements. Adjusting parameters dynamically updates the entire model, facilitating easy iterations and design exploration. 3. Extensibility. Grasshopper supports numerous plugins such as Kangaroo for physics simulations and form finding, Ladybug and Honeybee for environmental and energy modeling, Galapagos for evolutionary and optimization algorithms, Elk for importing geographic data from OpenStreetMap. 4. Integration with other tools. Grasshopper can be combined with other tools and software for enhanced functionality. For example, it integrates well with Python, C#, and VB.NET for custom scripting, and can interface with software like Autodesk Revit and Unity for extended workflows. Applications of Grasshopper. 1. Architecture. Grasshopper is widely used for creating complex building forms, facades, and structural components. It allows for innovative designs that respond to environmental factors, optimizing both aesthetics and performance. 2. Engineering. Engineers use Grasshopper for structural analysis, simulation, and optimization. It helps in creating efficient structures by analyzing loads, stresses, and material properties. 3. Product design. In product design, Grasshopper facilitates the creation of intricate patterns and forms. Designers can quickly prototype and iterate designs, adjusting parameters to explore various possibilities. 4. Art and sculpture. Artists leverage Grasshopper to generate unique, algorithmically driven art pieces. The tool's ability to produce complex, organic forms makes it ideal for modern sculpture and installation art. Thanks for that. I want to create a interesting pattern in Grasshopper in a 2D manner. Are there any tools you could recommend for creating a interesting, easy pattern in Grasshopper? Creating interesting 2D patterns in Grasshopper can be a fun and engaging task. Here are some tools and techniques you can use to create various patterns. Tools and techniques. 1. Paneling tools. Paneling tools plugin. This plugin helps create grid-based patterns that can be manipulated to form interesting designs. It's great for generating both regular and irregular grid patterns. 2. Attractors. Using attractor points or curves can create patterns that vary based on proximity to the attractors. This technique is useful for creating gradient-like effects where pattern elements change size, shape, or density based on their distance from the attractor. 3. Voronoi patterns. The Voronoi component generates a Voronoi diagram based on a set of points. This is a popular method for creating organic and cell-like patterns. Example, use the populate2D component to generate random points within a boundary, then connect these points to a Voronoi component. 4. Graph Mapper. The Graph Mapper component allows you to manipulate data using predefined or custom graphs. It's a versatile tool for creating wave-like patterns, sine curves, and other mathematical patterns. Example, combine the divide curve component with the Graph Mapper to create sinusoidal or parabolic transformations of a grid. 5. Point grids. Create grids using the... So those all sound great. If I wanted to combine the Voronoi with the attractor point and the curve graph mapper, how would I do that? Can you explain the process in Grasshopper? Certainly. Combining Voronoi diagrams with an attractor point and the graph mapper in Grasshopper can create a dynamic and visually interesting pattern. Here's a step-by-step guide to achieve this. Okay, let's go. Step-by-step process. 1. Create a point grid. Use the populate 2D component to generate random points within a defined boundary, e.g. a rectangle. 2. Generate Voronoi diagram. Connect the output points from populate 2D to the Voronoi component to create Voronoi cells. 3. Add a tractor point. Add an attractor point using the point component. Place this point in the area where you want to influence the pattern. 4. Calculate distances. Use the distance component to calculate the distance from each Voronoi point centroid to the attractor point. 5. Use GraphMapper. Add a GraphMapper component and set its type, e.g. Bezier, sine, etc. Connect the distances to the GraphMapper to remap the distances based on the chosen graph curve. 6. Scale Voronoi cells. Use the scale component to scale the Voronoi cells based on the remap distances. Connect the original Voronoi cells to the G geometry input and the remap distances from the GraphMapper to the F factor input. Detailed steps. 1. Populate 2D. Drag the populate 2D component onto the canvas. Define the boundary using a rectangle or another closed curve. Set the number of points to generate. 2. Voronoi. Drag the Voronoi component onto the canvas. Connect the output of populate 2D, the points, to the input of the Voronoi component. 3. Attractor point. Add a point component and place it where you want the attractor to be. Optionally, make this attractor point adjustable using a slider. 4. Distance calculation. Add a distance component. Connect the output points from populate 2D to the first input of the distance component. Connect the attractor point to the second input. 5. GraphMapper. Add a GraphMapper component.
We'll go back to setting these things in a moment.
Right-click on the GraphMapper and choose the desired graph type, e.g. Bezier, sine. Connect the distances output from the distance component to the GraphMapper input. 6. Scale Voronoi cells. Add an area component to find the centroids of the Voronoi cells. Connect the Voronoi cells to the area component. Use the scale component to scale the Voronoi cells. Connect the Voronoi cells to the G geometry input, the centroids from the area component to the C center input, and the remapped distances from the GraphMapper to the F factor input. Final steps. 1. Adjust parameters. Play with the number of points in populate 2D, the position of the attractor point, and the graph curve in the GraphMapper to get the desired pattern. 2. Preview and fine-tune. Use Bake to transfer the final geometry to Rhino for further refinement or rendering. This process will help you create a dynamic Voronoi pattern.
That's great, thank you. If I wanted to use a point component to set a point in Rhino, can you explain the process of how to set one point?
To set up a point in Rhino using the point component in Grasshopper, follow these steps. Steps to set up a point in Rhino using Grasshopper. 1. Open Grasshopper. Open Rhino and then launch Grasshopper by typing Grasshopper in the Rhino command line and pressing Enter. 2. Add the point component. In Grasshopper, locate the point component. You can find it in the Vector tab under the Point panel, or simply double-click on the Grasshopper canvas to open the search bar and type the point. 3. Place the point component on the canvas. Drag and drop the point component onto the Grasshopper canvas. 4. Set the coordinates for the point. The point component has 3 inputs,
we're going with this
Y,
one.
and Z, which represent the coordinates of the point. To set the coordinates, you can either use number slider components or manually input values. Example using number sliders. 1. Add number sliders. Add 3 number slider components to the canvas by double-clicking and typing number slider. These sliders will be used to control the X, Y, and Z coordinates. Set the range and values for each slider according to your needs. For example, set the range from -10 to 10 for simplicity. 2. Connect sliders to the point component. Connect the output of the first slider to the X input of the point component. Connect the second slider to the Y input. Connect the third slider to the Z input. 3. Adjust the sliders.
Seems to be working so far.
Move the sliders to set the exact coordinates of the point. The point component will update dynamically as you adjust the sliders. Example using direct input. 1. Set coordinates directly. Alternatively, you can set the coordinates directly by right-clicking on each input of the point component and selecting Set Number. Enter the desired values for X, Y, and Z. Finalizing the point. 1. Bake the point. Once you are satisfied with the location of...
That's perfect, thank you. If I wanted to set a number slider, is there a quicker way to do it instead of typing in number slider and then editing the values?
Yes. There is a quicker way to set up a number slider in Grasshopper without having to type number slider and then edit the value each time. You can define the slider's range and value directly as you place it on the canvas. Here's how you can do it.
Okay.
Quick steps to set up a number slider. 1. Double-click on the Grasshopper canvas to open the quick search bar.
Yep.
2. Type the desired range and value in the following format: slider min to max or min max at value. 3. Press enter to create the slider with the specified range and value. Examples: 1. Create a slider from 0 to 10. Type 0 to 10 and press enter. This creates a slider ranging from 0 to 10 with an initial value of 5
that's not going to work,
default.
but
2. Create a slider with
good
a
enough.
specific initial value.
0
Type
to
0
10.
to 10 at 5 and press enter. This creates a slider ranging from 0 to 10 with an initial value set to 5. 3. Create a slider with specific range and value. Type -10, 10 at 0 and press enter. This creates a slider ranging from -10 to 10 with an initial value set to 0. Summary: quick search. Double-click on the Grasshopper.
Thank you for that. If I wanted to set a point that's editable in Rhino with the gumball arrows, how could I do that in Grasshopper?
To set a point in Rhino that is editable with the gumball arrows directly within Rhino, you can use the Human plugin for Grasshopper. This plugin allows you to create Rhino geometry that remains interactive and editable in the Rhino environment. Here's how you can do it.
Okay.
Next, steps to create an editable point in Rhino. 1. Install the Human plugin. Ensure that you have the Human plugin installed. You can download it from the Food for Rhino website. Please open your app to see this link. 2. Open Grasshopper and add components. Open Grasshopper within Rhino. 3. Set up the Grasshopper definition. Add a point component. Create a point using the point component, similar to the previous explanation. Add a point parameter component. Use the point parameter component from the Human plugin to allow editing in Rhino. 4. Connect components. Connect your point from the point component to the point parameter component from Human. 5. Bake with Human plugin. Use the bake geometry component from Human to bake the point into Rhino.
I don't know what we're going on
Ensure
about.
that interactive mode is enabled, which allows you to manipulate the point with the gumball tool in Rhino. Detailed example. 1. Add a point component.
Okay, good enough. If I wanted to reference a point in Rhino, the point is in Rhino. If I wanted to reference the point in Grasshopper, how could I do that?
To reference a point that already exists in Rhino and bring it into Grasshopper, you can use the point parameter component to link to the Rhino geometry. Here are the steps to do that. Steps to reference a point in Rhino from Grasshopper. 1. Place the point in Rhino. Ensure you have a point placed in your Rhino model. You can create a point by typing point in the Rhino command line and clicking on the desired location.
Yep.
2. Open Grasshopper.
Cool.
Open Grasshopper by typing Grasshopper
I
in
stuttered
the
there a
Rhino
little bit,
command
so
line and pressing enter.
good to know that
3.
GPT
Add
can
a
pick
point
up on that
parameter
and figure out what I was trying
component
to say.
Grasshopper. In Grasshopper, go to the Params tab and find the point parameter, a green icon.
Green?
Drag and drop the point parameter onto the Grasshopper canvas. 4. Set one point.
Okay.
Right-click on the point parameter component on the Grasshopper canvas. Choose Set One Point. This will allow you to select a point from the Rhino model. Click on the point in your Rhino model that you want to reference. The point will now be linked to the Grasshopper point parameter. 5. Use the referenced point. You can now use the referenced point in any Grasshopper component that requires a point input. Summary: place point in Rhino. Create the point in your Rhino model.
So for the Voronoi script that you were describing earlier, where would we plug this point into?
To incorporate the referenced point from Rhino into the Voronoi script described earlier, you would use it as an attractor point.
Yep.
This point will influence the scaling of the Voronoi cells based on their distance from it. Here's how to integrate the referenced point into the script. Steps to integrate the referenced point. 1. Reference the point from Rhino. As described earlier, use the point parameter component to set and reference a point from Rhino. 2. Use the referenced point as a tractor. Connect the referenced point to the distance component to calculate distances between each Voronoi cell centroid and the attractor point. Detailed steps.
Okay.
Populate
See
2D.
if she knows where to plug it
Use
into.
the populate 2D component to generate random points within a defined boundary, e.g. a rectangle. 2. Generate Voronoi diagram.
Oh,
Connect the
okay.
output
Whole thing
points
again.
from
Cool.
populate
Good
2D
enough.
to the Voronoi component to create Voronoi cells. 3. Reference point as attractor. Add a point parameter component and set it to reference the point in Rhino as described before. Right-click on the
Cool.
point parameter, choose Set One Point, and select the desired point in the Rhino model. 4. Calculate distances. Use the distance component to calculate the distance from each Voronoi point centroid to the attractor point, the referenced point. Connect the output points from populate 2D to the first input of the distance component.
Yeah, cool.
Connect the referenced attractor point from the point parameter to the second input of the distance
Fair.
component.
Nice.
5. Graph mapper. Add a graph mapper component. Connect the distances to the graph mapper to remap the distances based on the chosen graph curve. 6. Scale Voronoi cells. Use the
Yeah, that
scale
works well.
component to scale the Voronoi cells based on the remap distances. Connect the original Voronoi cells to the geometry input and the remap distances from the graph mapper to the F factor input.
Yep.
Complete example 1, reference point from Rhino. Add a
Yeah,
point
that
parameter
works
to
well.
reference the attractor
Let's see
point
if she
in
can help
Rhino.
here.
Right-click on the...
So my Voronoi cells extend beyond the bounds of the initial rectangle that is setting all the points. How do I make them not extend beyond the boundary of the rectangle?
To ensure that the Voronoi cells do not extend beyond the bounds of the initial rectangle, you can use the boundary or trim with region component in Grasshopper to trim the Voronoi cells to fit within a specified boundary.
Boundary or trim?
Here's how you can do
Okay.
it. Steps to
Don't know
trim
if that's what I
Voronoi
would do.
cells. 1. Create a boundary. Define the boundary, rectangle, that you want the Voronoi cells to stay within. 2. Generate Voronoi cells. Use the populate 2D component to generate points within the boundary. Connect the points to the Voronoi component to create Voronoi cells. 3. Trim Voronoi cells with boundary. Use the boundary or trim with region component
Unless she's talking
to
about this.
trim the Voronoi
which
cells
is-
to fit within the boundary. Detailed steps. 1. Create boundary. Create a rectangle using the rectangle component or any other closed curve component. This rectangle will serve as the boundary for the Voronoi cells. 2. Populate 2D in Voronoi. Use the populate 2D component to generate random points within
At least
the
GPT
rectangle.
describes it
Connect
in
the points
lots of different levels
to
of
the
detail.
Voronoi component to generate the Voronoi cells. 3.
It'd be really good for someone
Trim
learning.
with region. Add the boundary or trim with region component to the canvas. Connect the Voronoi cells to the geometry input of the trim with region component. Connect the boundary, rectangle, to the region input of the trim with region component. Example script 1, define boundary. You can see the code in our conversation history. 2, generate points. You can see the code in our conversation history. 3, create Voronoi cells. You can see the code in our conversation history. 4, trim Voronoi cells. You can see the code in our conversation history. Summary.
Good enough. Good
define
enough.
Boundary.
Thanks for that. If I wanted to take this 2D diagram and make it three-dimensional vertically, what's the best way to do that? I'm just going to plug this into boundary here. It's a little bit easier.
To extrude your 2D Voronoi diagram into a 3D model in Grasshopper, you can use the extrude component to give height to the Voronoi cells, turning them into 3D shapes. Here's how you can do it. Steps to extrude the 2D Voronoi diagram. 1. Create the 2D Voronoi cells. Follow the previous steps to create the 2D Voronoi cells and ensure they are trimmed to fit within the boundary. 2. Extrude the cells. Use the extrude component to give the 2D cells a third dimension by extruding them vertically. 3. Define the height. Use a number slider to define the height of the extrusion. Detailed steps. 1. Create 2D Voronoi cells. You should already have a setup that includes the populate 2D Voronoi and trim with region components to create and trim the 2D Voronoi cells. 2. Add number slider for height. Add a number slider component to control the height of the extrusion. Set the slider's range, e.g. 0 to 10, depending on how tall you want the 3D cells to be. 3. Unit Z vector. Add a unit Z component to create a unit vector in the Z direction. Connect the number slider to the factor input of the unit Z component to set the extrusion height. For extrude component, Add an extrude component to the canvas. Connect the trimmed Voronoi cells to the base input of the extrude component. Connect the unit Z vector output from the unit Z component to the direction input of the extrude component. Example Grasshopper script.
Does make it 3D.
1. Generate and trim Voronoi.
That's great. If I wanted to connect the extrude to reference the attractor point as well, how would I do that?
To connect the extrusion height to the attractor point, you can use the distance from the attractor point to each Voronoi cell centroid to influence the height of the extrusion. Here's how to do it. Steps to integrate the attractor point for extrusion height. 1. Calculate distances to attractor point. Use the attractor point to calculate the distance from each Voronoi cell centroid to the attractor point. 2. Remap distances using Graph Mapper. Remap these distances using the Graph Mapper to get a desirable range for extrusion heights. 3. Use remap distances as extrusion heights. Use the remap distances to control the height of the extrusion for each Voronoi cell. Detailed steps. 1. Calculate centroids of Voronoi cells. Use the area component to find the centroids of the Voronoi cells. Connect the trimmed Voronoi.
We've already learned some of this information. Could you shorten the description to not include anything we've already gone over? And tell me again how to control the extrusion based on the attractor point distance.
To control the extrusion height of the Voronoi cells based on their distance to an attractor point, follow these streamlined steps. 1. Calculate distances. Use the distance component to measure distances from Voronoi cell centroids to the attractor point. 2. Remap distances. Use the Graph Mapper to remap these distances to a suitable range for extrusion heights. Extrude with remapped heights. Connect the remap distances to control the height in the extrude component. Steps in Grasshopper. 1. Calculate centroids. Use the area component to find centroids of the Voronoi cells. 2. Calculate distances. Connect centroids to the first input of the distance component. Connect the attractor point to the second
it's still explaining how to do
input of
everything,
the
so that
distance
is nice.
component. 3. Remap distances. Add a Graph Mapper component. Connect the distances to the Graph Mapper. 4. Extrude Voronoi cells. Use a unit Z component for the extrusion direction. Connect the remapped distances from the Graph Mapper to the factor input of the unit Z component. Connect the trimmed Voronoi cells to the base input of the extrude component. Connect the unit Z vector to the direction input of the extrude component. Example connections. Calculate centroid area. Connect Voronoi cells to get centroids. 2. Calculate distances. Distance input 1, centroids from area, input 2, attractor point. 3. Map distances. Graph Mapper, connect distances from distance. 4. Extrude, unit Z, input remap distances from Graph Mapper. Extrude base Voronoi cells, direction, unit Z vector. By following these steps, you can dynamically control the extrusion heights of Voronoi cells based on their distance from an attractor point. If you have any more questions or need further assistance, feel free to ask.
Yeah, the attractor point scale factor values seem to max out at 1 and don't extend throughout the full length of the graph. Is there a better way to define how far the scaling factor goes?
To better control the scaling factor and ensure that it extends throughout the full length of the graph, you can use the Remap Numbers component to more precisely define the range of your scaled values. Here's how to achieve this. 1. Calculate distances. Use the distance component to measure distances from Voronoi cell centroids to the attractor point. 2. Find min and max distances. Use the bounds component to find the minimum and maximum distances. 3. Remap distances. Use the Remap Numbers component to remap the distances to a new range suitable for extrusion heights. Define the target range using the construct domain component. 4. Graph Mapper, optional. Connect the remapped distances to the Graph Mapper if you still want to shape the distribution of the values.
But it could be nice.
5. Extrude with remapped heights. Use the remapped distances to control the height in the extrude component. Detailed steps. 1. Calculate centroids. Use the area component to find centroids of the Voronoi cells. 2. Calculate distances. Connect centroids to the first input of the distance
Should we
component.
actually use the centroids? I guess.
Connect the attractor
we could.
point to the second input of the distance component. 3. Find min and max distances. Connect the output of the distance component to the bounds component.
Yep.
4. Construct domain. Add a construct domain component and set it to your desired range for the scaling factors, e.g. 0 to 10. 5. Remap numbers. Add a remap numbers component. Connect the output of the distance component to the n input of the remap numbers component. Connect the output of the bounds component to the s input of the remap numbers component.
I mean, it could be numbers.
Connect the construct domain component to the t input of the remap numbers component. 6. Graph mapper optional. Add a graph mapper component. Connect the remapped distances from the remap numbers to the graph mapper. 7. Extrude Voronoi cells. Use a unit Z component for the extrusion direction. Connect the remap distances from the remap numbers or graph mapper to the factor input of the unit Z component. Connect the trimmed Voronoi cells to the base input of the extrude component. Connect the unit Z vector to the direction input of the extrude component. Example connections. 1. Calculate centroids. Area.
So the graph mapper looks like it has a set domain from 0 to 1, even though our remap numbers go from 0 to 10. How do we update the range in the graph mapper to reflect the values that we want?
To ensure the graph mapper properly reflects the desired value range, you need to adjust its domain to match the remapped values. Here's how to update the graph mapper domain in Grasshopper. 1. Set up remap numbers. Use the remap numbers component to remap distances to your desired range, e.g. 0 to 10. 2. Set the domain of the graph mapper. Add a construct domain component to define the range for the graph mapper to match the output range of the remap numbers component. 3. Reparameterize the graph mapper. Connect the construct domain component to the graph mapper to set its domain. Tab detailed steps. 1. Remap numbers. Remap the distances. Use remap numbers to map distances to the target range, e.g. 0 to 10. Construct domain. Define this target range using the construct domain component. Set 0 as the start and 10 as the end. 2. Graph mapper. Add graph mapper. Place a graph mapper component on the canvas. Set domain. Right-click on the graph mapper component and select Reparameterize. This will adjust the internal domain to match the incoming data range. 3. Connect components. Construct domain. Connect the construct domain output to the graph mapper. Remap numbers. Connect the remap distances to the graph mapper. Example connections.
I don't know about that
remap
one.
Distances. Remap numbers and distances from distance component. S. Domain from bounds component.
I mean, we can
T.
forego
Constructed domain 0
the
to 10.
graph mapper.
2. Graph mapper. Construct domain.
Is there a better graph mapper that lets us input the start domain and the target domain? Just gonna get rid of this for now and replace it.
In Grasshopper, the standard graph mapper component does not allow direct input of custom start and target domains. However, you can use a combination of components to achieve similar functionality. Here's a more flexible approach. Custom graph mapping workflow. 1. Remap numbers to 0 to 1 range. First, remap your values to a 0 to 1 range using bounds and remap numbers. 2. Apply graph mapper. Use the graph mapper to map the 0 to 1 values to a desired curve. 3. Remap to final target range. Finally,
are there plugins that have better graph mappers? I wonder what that sound means.
Yes, there are several plugins for Grasshopper that provide advanced graph mapping capabilities beyond the standard graph mapper. Here are a few notable ones. 1. Remap Plus. Remap Plus is a plugin that offers enhanced remapping capabilities. It allows for more flexible and complex data transformations, providing better control over remapping ranges and domains. You can download it from Parametric House. More details and download, please open your app to see this link. 2. Graphic Plus.
Cool.
Graphic Plus is a plugin for creating advanced graphical representations, including scalable vector graphics, SVG. While primarily for graphical outputs, it includes advanced data manipulation tools that can enhance how data is visualized and transformed. More details and download, please open your app to see this link. 3. Lunchbox. Lunchbox is a powerful plugin that includes
Yeah.
various utilities for generating and managing data patterns, including advanced graph mapping tools. It provides more sophisticated methods for controlling data flow and visualization. More details and download. Please open your
Sure.
app to see this link. Using these plugins, you can achieve more precise control over your data transformations and visualizations in Grasshopper, allowing for more complex
Okay, I was
and
looking for
refined
rich graph
parametric
mapper,
models. If you have
but
any specific
that is
questions about
fine.
using these plugins, feel
If I want to have different values in the scale factor and different values in the extrude distance, how could I do that?
To have different values for the scale factor and the extrude distance for your Voronoi cells in Grasshopper, you can use two separate sets of data and apply them independently to each operation. Here's how you can do it.
Will it remember the remap?
Steps to separate scale and extrude values. 1. Calculate distances to a tractor point. Use the attractor point to calculate the distances from each Voronoi cell centroid. 2. Remap distances for scaling.
Okay, cool.
Remap the distances to a suitable range for scaling the Voronoi cells. 3. Remap distances for extrusion. Remap the distances to a different suitable range for extruding the Voronoi cells.
Yeah.
Detailed steps. 1. Calculate centroids. Use the area component to find centroids of the Voronoi cells. 2. Calculate distances. Use the distance component to measure distances from the centroids to the attractor point. 3. Remap distances for scaling. Add a remap numbers component. Use the bounds component to find the min and max distances. Use a construct domain component to define the target range for scaling, e.g. 0.5 to 2.
Yep.
Connect the distances to the remap numbers component and remap to the target range for scaling. 4. Remap distances for extrusion. Add another remap numbers component.
Okay.
Use a separate construct domain component to define the target range for extrusion, e.g. 0 to 10.
Yep. Separate.
Connect the distances to this remap numbers component and remap to the target range for extrusion. 5. Scale Voronoi cells. Use the scale component to scale the Voronoi cells. Connect the original Voronoi cells to the geometry input of the scale component.
Yep.
Connect the centroids to the center input of the scale
Yep.
component. Connect the remapped distances for scaling to the F factor input of the scale component. 6. Extrude Voronoi cells. Use the extrude component to extrude the scaled Voronoi cells. Use a unit Z component to create the extrusion direction. Connect the remapped distances for extrusion to the factor input of the unit Z component. Connect the scaled Voronoi cells to the base input of the extrude component.
Did it say anything
Connect
about using the
unit
same
Z
bounds
vector
or
to
different
the
bounds?
direction input of the extrude component. Example connections. 1. Calculate centroids.
We'll see.
Area. Connect Voronoi cells to get centroids. 2. Calculate distances. Distance input 1. Centroids from area. Input 2.
Yep.
Attractor point.
Yep.
3. Remap numbers for scaling. Bounds connect distances from distance. Construct domain. Set range for scaling, e.g. 0.5 to 2. Remap numbers. Input n. Distances. Input s. Bounds. Input t. Construct domain for scaling.
Okay.
4. Remap
Different
numbers
range,
for
but it's
extrusion.
fine.
Construct domain. Set range for extrusion, e.g. 0 to 10.
Yep.
Remap
Okay,
numbers.
sure,
Input
sure.
n. Distances. Input s. Bounds. Input t. Construct domain for
Okay,
extrusion.
I mean,
5.
yeah,
Scale
that
Voronoi
works.
cells. Scale G. Original Voronoi cells. C. Centroids from area. F. Remapped values for scaling. 6. Extrude Voronoi cells. Unit Z. Input factor. Remapped values for extrusion. Extrude base scaled Voronoi cells. Direction unit Z vector. By following these steps, you can independently control the scaling and extrusion of Voronoi cells using separate remapped values from the attractor point distances. This allows for more nuanced and varied transformations of your 3D model. If you have further
Yeah, we got
questions or
there.
need more assistance,
That is
feel free to
cool.
ask.
That's awesome. Could we add color to this also using the attractor point to define a gradient color?
To add color to your Voronoi cells, creating a gradient based on the distance from the attractor point, you can use the gradient component in Grasshopper. This will allow you to apply a color gradient influenced by the attractor point. Here's how to do it. Steps to add gradient color. 1. Calculate distances to attractor point. Use the attractor point to calculate the distances from each Voronoi cell centroid. 2. Remap distances for color gradient. Remap the distances to a 0 to 1 range suitable for the gradient component.
Sure.
3. Define the color gradient. Use the gradient component to define the color gradient based on the remapped distances. 4. Apply colors
0
to
to 1.
Voronoi cells. Use the custom preview component
Just
to
do
apply the
that.
colors to the Voronoi cells. Detailed steps. 1.
Okay.
Calculate centroids. Use the area component to find centroids of the Voronoi cells.
Curious how we'll
2.
get from here to here.
Calculate distances. Use the distance component to measure distances from the centroids to the attractor point. 3. Remap distances for gradient. Add a remap numbers component. Use the bounds component to find the min and max distances. Use a construct domain component to define the target range 0 to 1.
Sure,
Connect the
could do that as
distances
well.
to the remap numbers component and remap to the 0-1 range. 4.
Yep.
Define color gradient.
Yep.
Add a gradient component. Right-click on the gradient component to set the colors you want to use in your gradient.
I'll have to right-click on the
e.g.
dots,
from
but close
blue
enough.
To red.
Blue to
Connect
red.
the remap
Okay,
distances
sure.
to the T input of the gradient component. 5. Apply colors. Add a custom preview component. Connect the
Yeah.
Voronoi cells to the G
That works.
geometry input of the custom preview component. Connect the colors from the gradient component to the S shader input of the custom preview component.
You could figure it out, I guess.
Connections. Calculate centroids area. Connect Voronoi cells to get centroids. 2. Calculate distances. Distance input 1, centroids from area. Input 2, attractor point. 3. Remap distances for gradient bounds. Connect distances from distance. Construct domain set range 0 to 1. Remap numbers input and distances. Input S bounds. Input T construct domain. 4. Gradient. Gradient set colors for the gradient. Input T,
I'm just
remap
gonna
distances from remap numbers. Custom
Change this real quick.
G, Voronoi cells. S, colors from gradient. Summary, 1. Distance calculation.
Just 'cause I like that better,
Distances from
but-
centroids to attractor point.
Okay.
2. Remap numbers.
That
remap
works.
distances to a 0
That
to 1
does
range.
work.
3. Gradient component.
Looks pretty good,
Define and
too.
apply the color gradient based on the remap distances. 4. Custom preview. Apply the colors to the Voronoi cells. By following these steps, you can create a color
Perfect, thank you. That worked out great. That's all I need for now, but I'll give you some more questions in the future if I come across them. So thank you.
You're welcome. I'm glad to hear that it worked out well for you. Feel free to reach out anytime you have more questions or need assistance with your projects in the future. Have a great day.
That's awesome. We'll just give that a thumbs up. And it's got everything we talked about written down and spelled out for us to follow along if we forgot anything. It was very in-depth. Very, very in-depth. Yeah, GPT probably didn't need to keep repeating itself so much, but I mean, for a beginner at Grasshopper, it might be helpful to hear the description of what we're going to do, an overview of how we're going to do it, and then detailed steps. I mean, I thought that was pretty nice. It had great recall. If we were talking about something else, like how to set up a slider or how to define the bounds for a graph mapper, and then just hit it with a, how can we add color to this? It seemed to pick up like old memories of the conversation really, really well, and was able to recall knowledge from before to tell us how to do something more without even any detailed information, just kind of like a vague idea of like, how do I do this thing? And it picked up pretty well. Yeah, I probably wasn't the best at describing what I wanted to do to it. You know, I know Grasshopper pretty well, so I could describe what I want to do in a very technical manner. But that's not going to be too helpful for the majority of people. So, I mean, I thought it did pretty well that I was able to just say kind of what I wanted to do, and then it told me exactly how to do it. You know, a Voronoi is a pretty, starter diagram. It's a introductory thing. I mean, I even asked it at the very beginning, like, what are some, basic operations that I could do to make an interesting pattern. It gave me the idea of using a Voronoi and a graph mapper to make an interesting pattern and an attractor point as well. And then, I mean, I just followed it from there. So overall, with using 4o with the voice chat, I think it did pretty well. And it was really easy to just chat to it and keep working while I was talking. It's a lot easier than having to go back and forth between a browser to talk to GPT and then back to Grasshopper. Having it talk to me was just, I mean, it was so nice. So really interested to see where this will go in the future. It already looks amazing right now. So maybe we'll try in the future to hit it with some more complex concepts in Grasshopper and see if it can give me the steps to create the script. Maybe that's for another video. I have tried GPT in the past with Grasshopper, but had only gotten good results out of the scripting, either asking it for Python code or C# code. And I mean, it could do okay with that. I mean, that is more common as a coding language. Visual scripting, though, it was able to describe to me exactly how to set up a visual script, which was pretty awesome. Hopefully someday it can just give us like a Grasshopper file, just like it can write us code. But you know, that's more than just text, so yet to be seen how that could happen. But yeah, overall, really excited about this. Maybe we'll try to make some, you know, really intricate jewelry piece next time and see what it can do. Maybe explore some plugins that aren't just base Grasshopper things. Would be interested to see if it knew some Dendro or Pufferfish or any other plugin. So, you know, really cool. So would recommend, if you're learning Grasshopper, to just talk to GPT-4o and have it explain what you're thinking about and how to build this code. And yeah, hopefully we'll post more about this in the future. I also have a Patreon where we do more cool stuff like this. That'll be linked in the description below. With my Instagram as well, a lot of fun stuff on there. But you know, hopefully that was interesting. You know, GPT-4o has only been out for a few days at this point, so really cool to see that it can do all this and just talk to me like a person, and throw in ums and ahs in the speech too, which was very uncanny valley, but I don't know, it was nice. So yeah, hope this was interesting. Check back for more videos, and I'll see you next time. Bye.